find similarity in right triangles. So we've already found similarity in triangles. We're going to associate specifically to right triangles only. Don't all right triangles already have an angle in common?
Yeah.
90-degree angle. So let's look through here at the review. So the altitude of a triangle is a segment from a vertex to the opposite side that is what? Perpendicular to that opposite side. In an isosceles triangle, number 2, the altitude to the base divides the triangle into 2 blank triangles. Let's think about this. If this right here is an isosceles triangle, don't you know that CA and CB would be what? Congruent. So I could put a tick mark here and a tick mark there. Here a tick mark, there a tick mark, everywhere a tick mark. Just making life exciting. And then don't they share a side? Guys are so... That was my best joke ever. Don't they share a side? Okay. Now at this point, if we just left it like this, could I prove the triangle's congruent? Is this an included angle or an unincluded angle between those two sides? It's unincluded. So right now, isn't it SSA? Can we prove triangles congruent with SSA? That's a bad word spelled backwards? No. So instead, remember that when this altitude right here, doesn't it bisect this vertex angle and doesn't it bisect this side? So I can also put 3 tick marks, if I can fit them in there, here, here, and here. So by SSS, aren't those triangles congruent? I could also have said by SAS because this angle here is congruent to that angle there, and aren't those 2 angles here, the base angles, congruent? So by SAS, I could have also proven the triangle is congruent. So there's a variety of ways you can prove the isosceles triangle is congruent, but it divides the triangle into 2 congruent triangles, not 2 isosceles triangles, but 2 congruent triangles, 2 congruent right triangles. Circle the altitude of triangle ABC. What's the altitude? CD. That was a toughie, right? All right, so then the geometric mean. You're right, Olivia. This is a tough one. So the geometric mean is really just this formula right here. Wait till we get the geometric mean in a triangle. That's the harder one. But the geometric mean is essentially 2 positive numbers, A and B. So right here, those are called your extremes. Where X becomes that geometric mean. In other words, it's a number that's in between those 2 other numbers, A and B. And it should be positive. There's no negative values on this geometric mean. And so all it is a proportion that you're setting up. So this is just an example of the geometric mean between 4 and 10. So 4 and 10 are your extremes. They go on one diagonal to each other. On the other diagonal in the proportion, you're always going to put X and X. Okay? So when you cross multiply and solve, X times X becomes an X squared. They don't show this part. So let's go ahead and show it over here. Your cross products would be X squared equals, what's 4 times 10? 40. And then how do you solve for X? You take the square root of both sides, and technically when you take the square root of 40, it should be a plus or a minus, but because we know that X and A and B are all positive numbers, we're going to ignore the negative. And so when I take the square root of 40, I get X is equal to the square root of, let's factor out 40. 40 is 4 times 10. 4 has 2 2's in it, so 2 times 2. 10 has a 2 and a 5 in it. Can't I pair up those 2 2's and bring them out front as 1 2? And then you multiply what's left over. So do you see how they got a 2 out in front and a 10 underneath? So it's 2 red 10. Yes?
What do they use the geometric mean for?
Oh, you'll see. We're going to use it to find various parts in a right triangle.
Like is it like a distance thing?
Yes. Yes. But if you think about a mean, it's a number that's in between 2 other numbers in this case. And so we are going to use the geometric mean to find lengths. So which proportion, number 4, which proportion can you use to find the geometric mean of 5 and 15? So 5 and 15 are, on this proportion, are they on a diagonal to themselves? Nope. So we're going to cross that one out. On this one, is the 5 and 15 on a diagonal to themselves? Nope. So we're going to cross that out. How about this one? Yes. And then see how it's x and x on the other diagonal? That one so far looks good. What about this one? Are they on a diagonal to themselves? No. So we're going to cross this out. And so C is your answer. Now, having said that, could I have written the 5 and the 15 on this diagonal and the x and x on this diagonal? Would that also be acceptable to find the geometric mean? Yeah, because you would have the same cross products. So to be honest, you don't have to set it up as C looks like, but C is your official setup. Then number 5, the geometric mean x of A and B is, and I don't really care if you memorize that because I don't teach it that way. So I don't really care about 5. Let's look at number 6. So let's set up the geometric mean for number 6 here. So if they've given me the numbers 3 and 7, I'm going to set up my proportion, and I'm immediately putting 3 and 7, bless you, on one diagonal to themselves. What do you put on the other diagonal? So you're going to put x and x, and then you're just going to solve that proportion. So cross multiply x times x is x squared equals, what's 3 times 7? 21. And then you're going to take the square root of both sides, and then x becomes, are there any perfect squares in 21? 21 is just 3 times 7, right? Both prime numbers, so you cannot simplify that any further. So your answer is the square root of 21. So the geometric mean x is the square root of 21. And so this is the answer we're looking for here. Number 7 is an interesting one. Circle the geometric mean of radical 3 and radical 3. What number is in between radical 3 and radical 3? Well, let's look to see how that plays out. And so let's take the two numbers that they gave us. Whoops, I'm going to use blue this time. So let's take those two numbers, and we're going to set them on the geometric mean. Well, we're going to set them on a diagonal to themselves. What do you put on the other diagonal? So x and x. So what's x times x? So we get x squared equals, what's radical 3 times radical 3? 3. When you solve for x, you take the square root of both sides, and we're only doing the positive square root. So doesn't x equal the square root of 3? So when the numbers are the same, isn't the geometric mean the same? And if you took the mean of 2 and 2, to find the mean, don't you add up the numbers and divide by the total number that you have? So if you take 2 plus 2, what's that? 4 divided by 2, what do you get? 2. So it makes sense.
Are we ever going to get like one that you
Yes, you could. Absolutely. Okay, so let's look at the second slide. Oops, I didn't want that. Oops. Okay, so let's look right here. Key concepts. Theorem 7-3 has two corollaries to it, and you see this lovely picture, and I'm going to try to simplify things, and in actuality, I will give you 2 days on this lesson. So don't panic, because you're going to come back tomorrow, and you should have a lot of questions. Okay? So what's going to happen is you're going to have this right triangle, and I always draw my right triangle no matter how they give it to me, with the right angle pointing up in the air. And the hypotenuse goes down here. Then what they've done is they've taken an altitude from the right angle, which in this case is C, straight down to the hypotenuse, creating 2 additional right triangles. So actually I have 3 right triangles within here. So I have one here, and then the overall right triangle. And what I would like you to look at is, on here I want you to change this to L sub 1, because that's the leg of the overall big right triangle, and I want you to mark this as L sub 2. And then I want you to take the hypotenuse here from A to B, And this hypotenuse has been cut into two pieces by this altitude CD. And so we're going to label these two pieces of the hypotenuse, this one here as H sub 1, and this one here as H sub 2. And what they've done is they've given you two different corollaries to find measures within this triangle. And if you look at corollary 1, so let's move this up just a smidge. If you look at corollary 1, they're saying that side AD is part of the hypotenuse, is to side CD, which is the altitude, as side CD, again the altitude, is to side DB. Isn't that the other part of the hypotenuse? So I want you to mark these. Again, this is H sub 1 and this is H sub 2. And then we're going to label this as the altitude. There are two parts in the overall big right triangle that can be considered the geometric mean. As you can see here, CD is on the geometric mean diagonal, isn't it? And isn't CD our altitude? I like to call this my altitude rule. And instead of memorizing what that proportion says, so we're going to call this the altitude rule. We have an altitude rule and we have a leg rule. The legs of the right triangle right here, the legs here, can be the geometric mean or this altitude. So look at what the piece that can be a geometric mean in the overall big triangle does. So this altitude here, it cuts the hypotenuse into two pieces, doesn't it? And so notice that the two pieces that are cut of the hypotenuse are here and here. So I like to write, instead of memorizing this, I like to write my proportion this way. So I put my altitude on the geometric mean, so altitude and altitude. Sometimes you know the altitude, sometimes you don't. Sometimes it's a variable, sometimes it's a number. And then I like to put the two pieces of my hypotenuse, H1 and H2, on the other diagonal. And you're going to know, in some format, 3 out of those 4. And we'll do some problems to where they make sense. Then what if we have instead, what if we don't have the altitude, but we have one or both of these legs? How does that work? So then what that does is we end up with, they show you with two different ratios. I want you to notice that they've color-coded this in turquoise, right? And so this CA is a leg. And notice how CA, or in their case AC, is on the geometric mean. The leg of the overall triangle can be a geometric mean. So they've put and identified the leg on the geometric mean and answer this. If this leg were to be extended all the way down past that hypotenuse, does it cut the hypotenuse into two pieces or keep it whole? I'm cutting all the way down. There's your hypotenuse. Does this leg cut the hypotenuse or keep it into one whole piece? It keeps it whole. So what I want you to realize is that on this other diagonal here, you've got the entire hypotenuse. Doesn't AB represent the entire hypotenuse? And this other piece on the diagonal is the piece of the hypotenuse that touches that leg. And so this is the hard part of this lesson, is you have to learn how to set up these proportions. So the leg rule is harder, so I'm going to write this one out. This is my leg rule. And instead of what they've written, because there's two different legs, so let's look at the other leg before we write our own general format. So this other leg is in green, CB. Notice that that leg is on the geometric mean diagonal. And again, does this leg cut the hypotenuse? Here's your hypotenuse. Does it cut the hypotenuse or keep it whole? It keeps it whole. It does not cut and separate that hypotenuse into two pieces. So notice that on the other diagonal here, AB again is the whole hypotenuse, and DB, isn't that the piece of the hypotenuse that touches the leg? So we have a recurring theme going on. So if I were you, I would write the following. Here's your proportion for the leg roll. So on the geometric mean diagonal, we're going to call this, if you recall, L1, and we're going to call this L2. And you can switch them up. It doesn't matter which is L1 and which is L2. you're going to put the leg, whichever leg you have, and it's got to be the same leg. You can't put L1 on one piece and L2 on the other. So it has to be the same leg. So you put the leg on the diagonal to itself, and then on the other diagonal, you're going to put the pieces of hypotenuse. H1 plus H2, that's the entire hypotenuse. Can you read what that says? Probably not. Let me try to write it a whole lot neater. So we're going to take H1 plus H2. That's the entire hypotenuse, because the leg does not cut the hypotenuse. And then on the other diagonal goes, and this is going to be a little bit of writing, goes the piece of the hypotenuse that touches the leg. So that could be H1 or H2. And in our case, this is H1 and this is H2. So I would prefer you learning your proportions this way. The altitude rule puts the altitude on the geometric mean diagonal, and because the altitude cuts the hypotenuse into two pieces, we put those two pieces on the other diagonal. So the other diagonal is always part of the hypotenuse, always. It's just, is it the two pieces or is it the whole hypotenuse and the piece that touches my leg? And then if you've got a leg rule, which means that you know one of the pieces, one of the legs of that triangle, you're going to put either L1 or L2, either one, not both. So you don't put L1 here and L2 there. So it's either L1, L1 or L2, L2. And then you put the entire hypotenuse here, the whole length, and then only the piece, either H1 or H2, that touches this leg that you put there. Yes?
Do the proportions under then matter?
The proportions under what?
Under
That's what I'm trying to explain to you. They're using two different proportions here, which we're writing out those proportions in words here so they make a little bit more sense. Because I don't like to memorize A's, B's, and C's because it can be different depending on pictures. So we like to think of it in terms of the leg of the overall big triangle, and then the other side of that overall big triangle that's opposite the right angle is your hypotenuse. So we like to split that into two pieces because the altitude cuts that into two pieces.
So AB would be AD plus DB?
Correct. Correct, which is H1 plus H2. So I want you thinking of this and this one, and this one. That's what I want you studying. And that's what you'll hear me say when we set up our problems. I don't like these here. Of course, they're textbook oriented, but they only pertain to those specific pictures. Well, those pictures can change, and those letters can change. The only thing that can be a geometric mean is an altitude of the big triangle or the leg of the big triangle. Then on the other diagonal goes pieces of the hypotenuse. So those are the only pieces you're going to see. So let's go ahead and look at some examples. We're not going to finish 8 and 9, so let's go on to, let's look at problem 1. In your homework, they're going to want you to find similar triangles, and to be quite honest, I'm really not as interested in those as I am in you finding the geometric mean. But let's just go ahead and talk about this just for a minute so we can look at it. We're going to write the names of the triangles here, and I'm going to write out the triangles. So notice how they flipped the picture all of a sudden. Haven't they flipped this picture? We have an overall big right triangle. Here's the right angle at P. That's the angle that you're going to use to identify other angles. And then here's another right angle here at S and another one on the other side of S. So I'm going to take, anytime you take an altitude into the middle of the big right triangle, don't you create two smaller right triangles here? So we're going to redraw those two smaller triangles. So I would prefer to draw them so that they look like the big triangle. So here's the smaller with my right angle, and here's the bigger one. I'm trying to orient them the same direction as the bigger triangle. Now, if this triangle, if this is a right angle here, then these are going to be my right angles there. And on the smaller triangle, which is this one right here, isn't S the right angle? Agreed? So I'm going to take S and put it here for the smaller triangle. Then notice that the big triangle and the small triangle, don't they overlap at Q? So wouldn't you agree that they have Q in common? And that Q should be corresponding angles in those two triangles. So then I'm going to put Q right here. So that means Q's here. What letter is left that I haven't named for the small triangle? P. So that means P must go here. P. Then I have to take the medium triangle, which is this one here, and I've got to name that one. So again, if this is where my right angle is, because it correlates to that angle, isn't S where my right angle is on the medium triangle? So I'm going to use green this time. So this is my S for the medium triangle. And then if the medium triangle and the big triangle share, they overlap at angle R, shouldn't angle R correspond on both triangles? So that means this should be angle R as well. So I'm going to put angle R here. And then what letter is missing? Aren't we missing P? Because we're on this triangle here. So I should be missing P. So this right here is also P. But notice that on the three triangles, P on the medium triangle corresponds to Q on the smaller triangle and Q on the biggest triangle. So they want you to write here a similarity statement. So RPQ is the big triangle. So this is our big triangle. And then I'm going to put our medium triangle next and then our small triangle here. So here we have start with R on the big. So here's R on the big. Doesn't that correspond to R on the medium? Because here, this is my medium triangle, and this is my small triangle. So this becomes R also. And then P is next. So P corresponds to the right angle. So on the big one, S is the right angle. I'm sorry, on the medium one, S is the right angle. So then we have S. And that leaves us with P. So there's my similarity statement for the medium triangle. And then for the small triangle, again, I'm going to keep with the big triangle. So we've got R. So R is here. So on the small one, P corresponds to R. So this must be P. And then next comes P on the big triangle. So here's P on the big triangle, which is the right angle. So the right angle on the small is S. So next is S. And that leaves us with Q. And then they want you to write the three right angles. Well, on the medium triangle, the right angle is S, so that must be PSR, so angle PSR. And on the small triangle, the right angle is S again, so that must be QSP. Angles are named with three letters. And then, how do we know what the three smallest angles are? They gave you this one. What triangles does that one belong to? Yeah, so here's QRP. So that's this angle right here, which corresponds to this angle here on the small one, and this one here on the medium one. So we're going to start with the medium first, and so we're going to name this angle, and then we'll name that angle. So this angle would be what? PRS. So this is angle PRS. And then on the small, it would be QPS. And then finally, we can use our answers up above right here. Can't we use these answers to write similarity statements here? And notice that they've used RPQ. So they just want you to write, let's just say that this is big to medium, big to small, so they're saying that medium equals small, or similar. And so big to medium would be RSP, Big to small would be PSQ. And then medium would be RSP. And small would be PSQ. So you'll have a few questions on your homework where you have to do that. This is really the meat of the matter right here, finding the geometric mean. That's the tough part. So what is the geometric mean of 4 and 18? Actually, this one's easy because it's just two numbers. So notice that they've walked you through it here. So I don't have an issue with how they walked you through it. They put the numbers 4 and 18. I see 4. Where should 18 go? Obviously, that's the only place that's left. So we're going to put 18 here. X is on the diagonal for the geometric mean. Notice that it's X is to itself. So they didn't give you X in here. You're supposed to know that X goes on the second diagonal to itself. And so then cross multiply. You get 4. Technically, I never, on these cases, will multiply out 4 times 18. Is there a point to multiplying out 4 times 18? If you're going to take the square root of both sides, don't you have to tear apart 418 into its prime numbers anyway? So why bother to multiply them together? So I would just leave it as 4 times 18. Then, when you go to take the square root of both sides here, which is the part that kind of skipped, you get X on the left, and then I would change 4 into 2 times 2. And then what can you change 18 into? A 2 and 9, which is 3 times 3. So this gets extended all the way out. And so I can make a pair of 2's and a pair of 3's, right? What is 2 times 3? Because only take one of them out. 6. So we end up with a 6 out in front. And then whatever's left underneath, in this case, we have a 2. You multiply together, and that's what goes underneath. So if you have trouble finding and simplifying square roots, I would break everything down to their prime factors and then just circle pairs. And however many pairs you have, take it out front, multiply all those pairs together out in front, and multiply what's left over underneath. And then I'm not necessarily interested in you answering those corollaries. So let's go on to problem. So here's where it gets fun. I want you to ignore everything that they have over there. Let's just talk our way through it. So let's look at this problem that they've given us right here. This is a typical picture for a geometric mean problem. They have X here. What is X? What part of the big triangle? What's X? Altitude. What do you know the altitude can be? The geometric mean. We're always looking for pieces that could be the geometric mean in the picture. What else in this picture could be the geometric mean? The 20 inches, because it's a leg, right? So either this piece, or the altitude could be a geometric mean. Since I have two different things that can be a geometric mean, I will be setting up two different equations, or could be setting up two different equations, depending upon what they give me. What do these pieces represent here? The hypotenuse. So technically, this is H1, and this is H2. And we're going to call this piece over here L2 to remain consistent, and then this is our altitude, right? So X is our altitude. So if I'm to find X, I don't need the 20 inches. Because if you remember the altitude rule says that you're going to take the altitude, which is on the geometric mean diagonal, and doesn't it cut the hypotenuse into two pieces? So the altitude rule says this. So if I were you, I would always write out the rule and then plug in, so that enables you to memorize and learn that rule. So the altitude rule, the altitude is going to go on a geometric mean to itself, and then on the other diagonal is going to go the pieces of the hypotenuse, because the altitude cuts the hypotenuse into two pieces. So H1 and H2 go on that other diagonal. So all I have to do is plug in my values. So my values for my altitude is what? What do they label the altitude as? X. So X and X go here. Sometimes it's a number, sometimes in this case it's a variable. And then your H1 and H2 are 9 inches and 16 inches respectively. And we'll go ahead and put the inches in here so you can get your units of measure correct. And then you have a proportion, just solve algebraically. Don't we cross multiply? So we get x squared equals, and again, I'm not going to multiply the 9 times the 16, but what's inches times inches? It's inches squared. Then you're going to take the square root of both sides, and you get x is equal to, what's the square root of 9? 3, so that comes out in front. What's the square root of 16? 4, that comes out in front and gets multiplied. And what's the square root of inches squared? Inches. And so doesn't x equal 12 inches? And isn't 12 inches in between 9 and 16 inches? So the answer seems reasonable. You're always looking for that reasonable answer. So the question above said, they took a rather complicated story for this picture. They said points A, B, and C are located so that AB is 20 inches. So this is AB is 20 inches. And segment A, B, and BC were perpendicular, so they're telling you where the right angle is. Point D is located on AC, so that BD is perpendicular to AC, meaning they've given you an altitude. I probably would never give you a story like this right now without giving the picture associated with it, because it's hard enough to do this than to be given this and try to figure out the picture. And so they're just describing to you a robot traveling from one place to another. But aren't we finding length? Right? All right. So what I would like you to do is go grab your workbook from the back really quickly. So we're going to do number 26 from page 196, which looks like this. Any A, B, C's, and D's, which is why I don't want you memorizing their proportions that they have given you. I want you thinking in terms of parts of the overall big triangle. So not only does this not have A, B, C's, D's, and whatever, it also is oriented differently, isn't it? But we're looking for pieces on the triangle that they have given you that could be the geometric mean. Do you see any pieces here that could be the geometric mean, whether it's a variable or a number? What pieces? X, and X is what? A leg, right? Or Y, another leg. So we'd be using the leg rule because you either have leg or an altitude. Have they given you any information on the altitude? No. So we are not using the altitude rule is the easiest rule to use. So this one we're going to use the leg rule. So put over here leg rule. So the leg rule says that we are going to take the leg, and we have two different legs, so we have to do one leg rule for one and leg rule for the other, or you could use Pythagoras' theorem. You'll see that in a minute. So we're going to use, let's just say L1. We're going to put L1 and L1 here. So choose one of the two legs, we're going to put it on the geometric mean diagonal to itself. Then ask yourself this question. Let's assume that X is leg 1. Does this leg cut the hypotenuse? This is your hypotenuse. Does the leg cut the hypotenuse, or does it keep it whole if I cut right here? It keeps it whole. You ask yourself this because it helps you remember what the formula says. So we want the whole hypotenuse, this whole hypotenuse, on this part of the geometric or the other diagonal. So I'm going to take H1 plus h2, that's the entire whole hypotenuse. And then on the other missing part here, we always put the piece of the hypotenuse that's touching this leg. What piece of the hypotenuse, 1 or 9, is touching this leg? The 1. So that means that in our case, we'll just put piece that touches leg. I don't feel like writing out the whole thing. The piece of the hypotenuse that touches that leg. So let's go ahead and input the pieces that we know. So our leg 1, isn't that x? So we're going to put x and x to itself. Those had better be the same number, always. And in this case, it's the same variable. And then the entire hypotenuse is 1 plus 9. What's the piece of that hypotenuse that touches our leg? The 1. Right? Because this is that piece of the hypotenuse that's touching our leg. So that's why the 1 goes here. So then we're going to cross multiply. So we get x times x is x squared equals, doesn't this equal 10? What's 10 times 1? 10. And then take the square root of both sides, and we don't get a nice happy answer. Can you simplify radical 10? No. The only thing that multiplies give you 10 is 2 and 5, and we can't make any pairs, so it remains the square root of 10. There's your answer. We're going to keep doing these until you get comfortable with them. So let's do another one. So let's finish and find y. So I'm going to take and look at y happens to be a geometric mean as well. So we're going to use exactly the same formula here because both of these are legs, and so both of them will use that leg rule. So here's my proportion. So since y is my geometric mean, it's going to go on the geometric mean diagonal to itself. And then, since y is a leg, this leg here does not cut the hypotenuse into two pieces. It keeps it whole. So we're going to put the entire hypotenuse here just like we did on this one. So we're going to put that 1 plus 9 here as well. But the only difference between these two formulas is the piece of the hypotenuse that touches this leg is the 9. So instead of 1, we're going to put in 9 here because the piece of the hypotenuse that touches our leg is that 9. So when we cross multiply and solve, y times y is y squared equals, and again, this is 10 times 9. So I'm going to go ahead and write out 9 times 10. And I'm going to take the square root of both sides. Square root of y squared is y. And then the square root of 9. 9 is 3 times 3. And 10 is 2 times 5. So I'm able to pair up the 3's and bring a 3 out in front. And then multiply the 2 and the 5 together and leave that underneath the radical. So y ends up being 3 square root of 10. So there are the two legs to your right triangle. So let's look at, oh, we didn't actually finish that one. Let's go back to that one. All right, so let's look at 27. So for 27, we have this problem. Here's my overall big triangle. And then it's got an altitude coming this direction. And I have z here, and 6 here, and y here, and an x here. So we're going to find both x and y. Don't let me forget to find y. Is it a 2? Yeah. Oh, terrific. It's because I'm blind. That's nice. 2. We would have figured, I would have figured that out eventually. All right, so there we go, right? So what pieces in that overall big black triangle can be the geometric mean? X or y? Why? How come? One's an altitude and one's a leg. So we have to apply two different formulas because we cannot apply the leg rule and the altitude rule together. So let's find the altitude first because it's easier. So we're going to use the altitude rule. So for the altitude rule, the altitude goes in the geometric mean to itself. So the altitude in our case is y. So we're going to put y on the geometric mean to itself. And then on the other diagonal is always pieces of the hypotenuse. The question is it the two pieces of the hypotenuse or is it the whole hypotenuse and the piece that touches the leg? Are we using a leg here? No. And consider this, we're using the altitude. Does the altitude cut the hypotenuse into two pieces or does it keep it whole? This altitude, if I cut right here, does it cut the hypotenuse? This is your hypotenuse. Does it cut the hypotenuse into two pieces or keep it whole? Cuts it into two pieces. So those two pieces, which are 2 and 6, they go on the other diagonal. And then you just cross multiply and solve. So we're going to cross multiply. Y times y is y squared equals 2 times 6. I choose not to multiply 2 times 6 because I'm going to have to tear it apart anyway. So I'm going to take the square root of both sides. And I get y is equal to the square root of 2 times, and then 6 becomes 2 times 3. So what pair can I make? The 2, and so it comes out in front. So we get y equals 2, and then this 3 was left over, so don't we get a red 3? And there's our answer for y. So that's our altitude. Then we want to find x, which is a leg. So that means we're using the leg rule. Whoops. So all the leg rule says is this. Here's my proportion. The leg, which in this case is x, goes on the geometric mean to itself. And then the other diagonal, which was not supposed to be that, the other diagonal contains pieces of the hypotenuse here. The question is, does this leg cut the hypotenuse? Here's your hypotenuse. Does the leg cut the hypotenuse or keep it whole? Keeps it whole. So we're putting the entire hypotenuse, 2 plus 6, on one piece of that diagonal. Then this piece left over is still another piece of the hypotenuse, but it's the piece of the hypotenuse that touches this leg. Does 2 or 6 touch this leg? It's the 6. So that's how come I know the 6 goes there. And then we're just going to cross multiply and solve. X times x is x squared. And then what does 2 plus 6 give you? 2 plus 6? 8. And then we're going to do 8 times 6. So then we've got 8 times 6. And again, I'm leaving it unmultiplied because I'm going to tear it apart. And then we're going to take the square root of both sides. And square root of x squared is x. And then we have the square root of, what does 8 break into? 3 2's. And 6 is a 2 and a 3. And so I can make 2 pairs of 2's, and then the 3 is left over. So what comes out in front? Yes, because it's 2 times 2, which is 4, and then rad 3. And so there's our answer for x. So I want you to try those tonight, see how you do. I will not collect it tomorrow, so if we are spending too much time on the current assignments, stop and we'll finish it on Friday.